Hi students, welcome. Today we will work through the basics of algebra. This document says rules, but I like to refer to them as general knowledge, right? You must be wondering, why do we add variables? So a plus b, b minus c, a times a. Here we will address that question. Let's take a builder, right? This builder wants to create a foundation to build a skyscraper. He has the area, he has the breadth, and the length he does not know. We do know the area is equal to length times breadth, right? Let's say the breadth is 5, the area is 50. Now the builder wants to determine the length of the building, knowing that the area is 50 and the breadth is 5. So he or she will make L the subject of the formula by dividing both sides by B. So we've got our area divided by the breadth. So we take 50 all over 5, and this is equal to 10. The length is 10. Now this was intuitive, but what if it is a formula that's not well remembered in its other forms? For example, a circle. The common form is a is equal to pi r squared. Let's say the builder knows the area and wants the radius. The builder will not remember the formula for the radius, right? He will remember the formula of the area, which is pi r squared. So the builder will divide both sides by pi and take the square root, and we end up with a all over pi and the square root of that. So now the builder knows the radius. So knowing when and how to add variables makes our lives easier when working with complex calculations in the working environment and in yours currently. I think it's used in accounting, right? Where you have to balance that balance sheet and that nonsense. But let us continue with mathematics here. Commutative property of addition. That's the first one. Let's say a is 1 and b is 2. So that's 1 plus 2, which equals to 2 plus 1. Both sides of the equation is equal to 3. So all of these laws, you could say, they're all true, but I'm showing you in terms of numbers, so you have a visual picture. On the left side, we've got 1 times 2, and on the right side we've got 2 times 1. We see it's the same solution. The next one, the associative property of addition. So we've got 1 plus 2 plus, c we can make 3, and on the right side we've got 1 plus, open brackets, 2 plus 3. Just say we work with the brackets first. So 1 plus 2 is 3, plus 3 is equal to, I don't think so you can see that. So on the left side we've got 3 plus 3, and on the right side we've got 1 plus 4. The values in brackets is equal to, that's 5. So both sides now are equal, 6 and 6. Now let us move on to the associative property of multiplication. We've got 1 times 2 brackets over that times 3, which equals to 1 brackets 2 times 3. Now let us work with the brackets first. 1 times 2 is 2, multiplied by 3. You know what, let's move this aside, much better. So you've got 2 multiplied by 3, which is equal to 1 multiplied by 6. In brackets 2 times 3 is 6, and now we see both sides is equal to 6. Let us move on to the distributive property. A times B is AB, A times C is AC. The second one, A times C is AC, B times C is BC. If we put in numbers, you will see we will get the same thing. So 1 open brackets 2 plus 3 is equal to 1 times 2 plus 1 times 3, which is equal to 5. Let's work with the second one. We've got 1 plus 2 multiplied by 3, which equals to 1 times 3 plus 2 times 3, and this is equal to 9. Right? You see the left side and the right side are equal. This is to demonstrate that this is 1, anything multiplied by 1 is the same thing, and in brackets 2 plus 3 is 5, so that's fine. The second one, we've got in brackets 1 plus 2, which is 3, 3 times 3 is 9. Let us move on to the additive identity property. Any number added by 0 is unchanged. For example, let us take 100. Plus 0 is simply 100. Take 1 million. Plus 0, it's simply 1 million. You will also notice for the multiplicative identity property, any number multiplied by 1 does not change. Have a look at this. 100 times 1 is 100. 2 million times 1 is 2 million. Because 1 is singular, right? Now let us move on to the additive inverse property. So we've got A plus in brackets minus A. Now we multiply the positive by the minus sign. So imagine there's a 1 there. So positive 1 multiplied by minus A is minus A. So A minus A is 0. You need to remember this. A positive multiplied by a positive. I should write this in different colors. So a positive multiplied by a positive is a positive. Right? Then a negative multiplied by a positive is a negative. Right? Remember which law was that? Okay, anyways, A times B is the same as B times A. So positive times a negative is also a negative. A negative times a negative is a positive. So just say we have A minus open brackets minus A. This is in effect A plus A, which is 2A. Let's say we have A minus open brackets plus a, this is equal to a minus a, because a minus times a positive is minus. Then the final one, the multiplicative inverse property. This is a all over 1 multiplied by 1 all over a. And so we have a times 1 all over 1 times a, and this is a all over a, which is 1. Or we can look at it in this way. We can have a multiplied by 1 all over a. We don't have to make the denominators the same because it's multiplication, right? And we know the denominator is 1. Any value, so just take 1 million. We can divide that by 1 and the answer is still 1 million. We can take 500 million and divide it by 1. The answer will still be 500 million. We can even take negative numbers. Negative 8 all over 1 is negative 8. I think that's it. If you have any questions or recommendations, please leave them in the comments. And in the next video, we will work through the laws of exponents, or I would say the general knowledge of exponents.